Here's a video on how to use regression to help graph some of the shapes in your Desmos graphing project. So here's a picture of the Golden Gate Bridge, and let's say I want to come up with a line that represents one of these suspension cables right here. So I'm going to go ahead and plot some points to represent that cable. So here are my points to represent the cable. Now in my head I'm thinking there's probably not a perfect model that fits this. I might try a parabola to start, although I know a parabola probably will come up more like this, but let's go ahead and try a quadratic equation to fit this. So in an expression you're going to type in a basic quadratic equation, but you want to make sure to use the points that you've listed. So my points are called x1, y1. If I were to make another set of data points, they'd be called x2, y2. So down here, I want my regression equation to be y1, because again, remember my data points are with 1. And again, the minute you type the 1, it will put it as the subscript. And then instead of putting equals, you want to put this single squiggle line, which is right next to the 1 on your keyboard. And then you're going to go ahead and type in whatever parameters you want. So since I'm building a quadratic, I'm going to do a for a parameter, and then x1, remember my data point is x1, but I want this to be squared. Then I could do plus b, my second parameter, and I still want to do x1, and then plus c. So sometimes when I'm doing it, I forget I put the x1 on the first term, but then if I have any more x terms, I forget to use the proper subscript with it. But again, right away, it creates a regression. You can see the r squared value is 0.9787 right here. Here are my parameters. And in here you can see how it fits. And again, now it's not a perfect fit. It's okay. But again, if you're doing the Desmos project and you really want to try to fit everything, it's probably easier to focus on smaller areas of it. But let's try maybe something else would fit better. So in here you can see I already put in, I tried to do a sinusoidal equation. So I went ahead and put in, I'm still using my x1 and my y1, but I did a sine b x minus c plus d for all my a, b, c, d parameters. And if I turn this on, now the purple line comes in here, and if I turn the blue line off, and we look at it, that actually fits, and again, limited. It fits well from this point all the way up to, it actually doesn't do a bad job with fitting all the way up to here. So this would be a good choice if I really wanted to hit just between the black points. And again, just a little more, I tried putting a quartic in here. And now that it hits the points well, but outside of the points, it doesn't hit that well. And in fact, when I'm looking at the quartic, I did happen to see that. Notice here the E, there is no E down here in my parameters, and that's because they actually use the E in creating the residuals. So don't use E as one of your parameters. So if I in fact go in here and change the E to F, wow, that really changes the shape, and that now looks almost perfect on there in terms of fitting my data points. And then what you can do is you can go ahead and rewrite the equation using those parameters that it just found in the regression. Notice here I went ahead and put in the equation, and I even at the end of the equation went ahead and put in the domain restrictions. So now if I turn this one on and turn our regression equation off, you see that you have a pretty nice match. Up here it's slightly off, and probably what I would have done is added an extra data point up here to see if it would fit well. And then the last thing also you should do is turn your data points off as well. So that's how you use regression to match a graph using Desmos.